Alright, so I chose to do my final project on sentiment analysis. And sentiment analysis, for those who don't know, gives you the ability to look at a stream of text and evaluate whether or not it has a positive or negative connotation tied to that text. So the way I did it was using a naive Bayes classifier. The training data that I used was already pre-classified. Here's a few examples of them. So these are lists of tweets, I think from like 2009 to 2016 potentially. So the 0 classifier is a negative tweet, 4 is positive. So the first program that I wrote was to extract all the data into individual Python files as lists. So this just processes all the data and then writes the positive and negative tokens to files called positive T and negative T. And then in my main program, where I do the sentiment predictions, I import these as lists as tokens. So once this program is run, the output looks something like this. So for my result set, I actually chose to take 5 Democrats and 5 Republicans and run the naive Bayes classifier against each of these public candidates to see what the results would be. So it runs through 5 candidates and it's 10 tweets each, and then it will spit out the total amount of positive and total amount of negative for the Republicans and Democrats. So in the bottom here, I print out the Democrats positive number and the Democrats negative, then the Republicans positive and Republicans negative. So you can see that overall it seems that, at least in this current political climate, given this selection of people, there's an overall negative connotation in this selection of Democrats. So I'll dive into how I went about doing this. So I tried 2 different ways. The second one was an unclassified approach, which was a lot more difficult than doing the naive Bayes. So I'll start with this classified function. So I grabbed the tweets using tweetpy and put them in lists of Democrats.py and Republicans.py, and then it goes through there and tokenizes each of the tweets into word tokenized items, and then I append that to a list called Democrat tokens or Republican tokens, and then I sift through these tokens and create frequency distributions to run in the classifier. And this classify function is what uses the naive Bayes calculations to predict the class. So in here I get a negative likelihood and positive likelihood, and that passes my frequency distribution of the test data, the frequency distribution of the negative tweets, the probability of negative tweets, and the total negative tweet count. And then this goes into the class prediction function, make class prediction, and it goes through each of the items in the test counts, which will be the test data frequency distributions, and it creates a prediction variable and multiplies every word in the text. You get the number of times that word occurred in the data given the class, and then I smooth that and divide by the total number of words in that class, and then I smooth the denominator as well. And then once you get that prediction number, you multiply that by the class probability, which is passed in for probability negative or probability positive. So then this comes back to the negative and positive likelihoods, and it will, I set an outcome variable and a likelihood variable, and if the positive likelihood is greater than the negative likelihood, I set the outcome to positive, and then the likelihood equal to the positive likelihood, because I want to display this later on. And then if the negative likelihood is greater than the positive likelihood, the outcome's negative. And then this returns to my classified function as a item in this list. So I append to the Democrat results the tweet, and then in the second item in that list will be the positive or negative connotation or sentiment. And from there I loop through all of the results and compare those against zeros or fours just to get a count, and then I increase those counts to just display at the bottom here. The second approach that I tried, I didn't end up getting it working 100%, but this was called the PMI approach, and this is based on a paper written by Peter Turney, and the PMI stands for Pointwise Mutual Information. So what I was doing is I would go through each of the tokens in the test data, and from there I would look at the part of speech tags, and you would try and figure out if there's an adjective followed by a noun, or if there's a verb phrase or an adverb followed by a verb phrase, and then you have another adverb followed by an adjective and a noun, or where it's not a noun in the third part of speech tag. So there's just a few different instances that you check for that are pretty specific to this paper that I was reading. And then what I did was go through the pairs that get appended to the pairs list from here, because you want to get adjectives followed by nouns. So like in this tweet here, you'd get something like unspeakable cruelty or dangerous countries, and then this would get appended to the pairs list. And then what I did from there was get a PMI calculation using this PMI function above. So it would look at the unigram frequency of the first word, and then I tried to smooth this data and divide by the length of those unigrams and get the probability of the second word over that length of those unigrams, and then take the log probability over the bigram frequency of those two words divided by that total bigram frequency count. So then it spits out a PMI calculation, which I store in a list, and then this list gets appended with the results, and then in this unclassified function I'll check if it's greater or less than the average for the Democrats and Republicans. This didn't seem to be working very well, and I'm sure there's a better approach, but the initial way that people were doing it was actually calling an API to Google's search engine and then getting the number of results to use a calculation there, which wasn't really doable. But so this was my project, and overall it was a lot of fun. I think trying to do the unclassified approach is a lot more difficult than the classified. So thanks for watching.